Hello, welcome to Learn Page by Page. I'm Sally, and in this video I've got this lovely word algebra challenge for you, where the sum, that's our first clue actually, of two numbers, x and y, is 66, but their difference, now that's our next clue, is 30. And the question is asking us, what is x and y when x is greater than y? So looking at this, we seem to have two equations. Well, we know we have two variables. Variables are just our unknowns. We have an x and we have a y. And we know if we add them, that's all sum means, is adding. We're going to get 66. But if we subtract them, now when I say subtract, we've got a certain order we're going to do our subtraction. They're telling us that the difference, now difference is the smallest number away from the biggest, and we're being told that x is our biggest number, so we have to do x minus y. Now that's our second equation, and when we have two equations we will solve them simultaneously. But in this video I'm going to solve them simultaneously using three different methods. Let's dive straight in. Now I've made that a little bit smaller for you. I hope it's not too small. Do let me know if it is in the comments, won't you? And before we dive in, let's break this question down. I like to call questions like this wordy questions, and I feel they need a little bit more attention because in maths we're used to just working with numbers, and when we get a wordy question, some people, even the greatest mathematical minds, find them a little bit challenging. And so if you do, approach them with the understanding that you've got words mixed up with numbers and the answer doesn't necessarily jump off the page. You know, when we have just numbers, and even just numbers and letters algebra questions, they're much easier than when we have these wordy questions. So if you struggle with wordy questions, do read them a minimum of 3 times. Your first read through, which we've already done, just roughly gives you an idea of what the question is saying. Your second read through, break it down. So let's go for our second read through, and that is the sum. Now, sum is just another word for adding in maths. And I'm being quite specific about that because when we were younger, particularly here in England, if someone said, if our teacher said, okay, it's time to do your sums, that could have included multiplication. But the correct word for sum is adding. Now, that could also mean adding negative numbers. So if you had -2 plus -3, well, that is still a sum because we will be adding those numbers. Incidentally, that simplifies to -2 minus 3 because the positive and the negative will become this negative. But I am digressing a bit, so let's go back to the question. So we have the sum of two numbers, x and y, is 66. Now their difference, and this is our next key word. Difference in maths means subtraction, but it means you will take the smallest away from the biggest. So I wrote smallest from largest. I feel that is easier if you're not a native English speaker. And then the rest of the question says, what is x and y when x is greater than y? So here they've told us that x is our largest value and y the smallest. So looking at this wordy question, we can see we have two algebra equations. The first one, we have x plus y is 66, and then our second equation, we're going to have x minus y equal to 30. So when we have two equations and two variables, we're going to solve them simultaneously. And there's two classic methods, but I'm not only going to go through two methods, I'll also show you a third method. And the first method will be the elimination method. The second method, the substitution method. And the third method, which is probably my favourite, and that's the graphical method. So let's dive into method 1, and that one's the elimination method. So what I've done here is I've brought the question here for us to extract the numbers from, and that's what I say, the third read or the fourth read get those numbers and letters out and then forget the actual worded question itself. So we were dealing with the sum, we know that's adding, of two numbers, x and y, is 66. So let's form an equation from that. And we have x plus y equals 66. The next equation was where we had the difference of those two values being 30, and we were told that x is the greater value, so we have x minus y equaling 30. And there what you've done is you've wrote a pair of equations, and when we write a pair of equations, what I always say to do is label them. And the first one, equation 1, pop your number in a circle so you're not going to get it confused with any of your numbers in your actual calculations. And that one is equation 2. Now we have all the information we need and we can actually get rid of the question. Now with the elimination method, what you're looking to do is you're looking to eliminate one of the variables. And the way you will do that, you're either going to subtract or add each term of each equation. So if we look, now I'm going to use quite a different colour. Let's use red. So when we examine this, we have an x here and we have an x here. They're both positive and they both have a coefficient, which is that number in front of 1. So to eliminate the x's, which is what we want to do, we want to get rid of one of the variables, all we would have to do would be subtract them. So we would do x subtracted by x, that would give us 0. That means we've eliminated it. But if we're going to subtract there, we have to subtract the y's from each other and we have to subtract the number terms as well. And I find the simplest way to do this is just put a subtraction sign there, showing we've got the tail of the y, it just confuses it a bit, but it's okay, and there. And then you have 3 separate calculations. The first one is going to be these x's. So you have x minus x, that will give you 0. The next one is your y terms, and don't forget the signs that's in front of them because that does change things. And here you have y minus a negative y, and do pop that negative y in brackets, or you may call it parentheses wherever you are in the world. But the reason you put it in brackets, you can't have these two signs next to each other like that. You do need to separate them with this bracket. And that's because as soon as you do that, you've actually got an invisible multiplication sign there. And so here we will have a negative multiplied by a negative, and that will give us a positive. And so that gives y plus y, which will equal 2y. And then our third calculation is this 66 minus 30, and that will equal 36. Now you won't have to write this out. I've done it just because it's the first time I've shown the elimination method, but you should easily be able to see that you are eliminating the x's, then the y's, and then the number term. And so let's write out what we have there. So we had the first one, x minus x, well that gave us 0. We're not going to write anything there because we don't write 0, it's unnecessary. Then we've got the y, the positive y minus the negative y, and that was our 2y. And then the last one, that was our 66 minus the 30, that gave us 36. So we have 2y equals 36. And now because we only have one variable, we can go ahead and solve that. And as we have the 2y here, we want this y on its own. Don't want this 2, this 2's in the way. And the 2 next to the y, well, a number next to a letter, that is just 2 multiplied by x. So again, I like to say it's an invisible multiplication sign. And so to get rid of the 2, we need to divide both sides by 2. So we divide this side by 2 and this side by 2. And I always write either side of the equation what I'm going to do. 2 reasons really. Firstly, if you are doing this for an exam, you will get the credits, you will get the marks for telling the examiner exactly what you've done. So you've divided by 2 on both sides of the equation, but also so I can go back and look over my work if I've made any little errors, and we all do. So here we've divided both sides by 2, so that means this side, 2 divided by 2, is 1. So that would give me 1y. I don't write the 1. And over here, 36 divided by 2, that is 18. Here I know y equals 18. And then what I'm going to do is I'm going to put this value of y being 18 into one of these equations. And I think the best one probably to put it in is the first one, equation 1, because y here is positive, and that's a positive value, so let's stick with that. So if I bring equation 1 down, that was x plus y equals 66. I have y being 18, so wherever y is, I'm going to replace that with 18, and that's x plus 18 equals 66. And I want x on its own, so I'm going to minus the 18 from both sides, and that gives me x equals 48. And to present my answer correctly, I will write x equals 48 and y equals 18. Then you should always go ahead and check your solutions. So if x is 48 and y is 18, well, let's take both equations. And the first one, we could see that 48 plus 18 does indeed equal 66, and 48 minus 18, that equals 30. And that's your proof. That's how you really know you've got the simultaneous equation correct. Now let's move on to the second method. Now with the substitution method, if you've ever done an algebra calculation such as this, say a plus 4 equals b, and you might have a question that says, what is b when a equals 2? So here, all you're going to do there is you're going to substitute a for 2. So you would have 2 plus 4 equals b, and therefore b equals 6. That is substituting. You are taking a value and replacing it for the letter. And this is exactly the same technique. So the first stage, what we want to do is we want to rearrange one of these equations to get the variable on its own. And I'm liking the look of the second equation because I'm going to focus on getting this x on its own by moving this negative y. And if we rewrite the equation, so we had equation 2, and that was x minus y equals 30. I'm going to plus the y, and you end up with x equals 30 plus the y. And so now we have x on its own. And then I'm going to look at equation 1, and where the x value is, I'm just going to replace that with 30y. So if we bring equation 1 down, and that was x plus y equals 66. And because we know that x is 30 plus y, and so wherever the x is, we're going to replace it with 30 plus y. In brackets, it keeps it a lot tidier, and it's mathematically correct. So we open our bracket, we put 30 plus y, close the bracket, then plus y equals 66. Now we just have one variable, and so rewrite that without the bracket. It's not going to change anything, but it's the way you do it. So 30 plus y equals 66. Collect your like terms. So the terms that are like each other are those two y's. So we're going to collect those. That just means add them together, combine them. We can't collect the 30 and the y because 30 is the number term and y's are the letter terms. So we have 30 plus 2y equals 66. And then we're going to subtract the 30. Let's move it up here actually. And subtract 30 from both sides. That gives us 2y equals 36. Divide both sides by 2. So y equals 18. And then you would do exactly the same step as you did with the elimination method, and you're just going to put 18 into wherever a y value. So we'll choose equation 1, and that was x plus y equals 66, and we had x plus 18, y is 18, equals 66. Subtract 18, and we have x equals 48. Again, write your solution out as x equals 48 and y equals 18. And then the third and final method we're going to go through is the graphical method. And like I said, that is actually my personal favourite. And here's the two equations, I brought them over. Now what we're looking for with a graphical method is a graph with two lines. So this is just a quick sketch of a Cartesian coordinate graph. We have an x-axis and a y-axis. That's our origin. And what we're aiming to do is we're aiming to plot two lines, one which will roughly go like that, the other which will go probably like that, and our solution would be this x value here and the y value there. It would be where those two lines cross, and that is how you solve a pair of equations with the graphical method. Now I'll roughly go through rearranging the equations, and then what we do, because we're going to have quite big numbers, so we won't draw the graph out here. I'll go over to Desmos, the graphing calculator, and we'll put the equations into that. But before we do that, let's rearrange each equation. There's equation 1. We have x plus y equals 66. And what I'm going to do is I'm going to rearrange these equations so they're in the general form of the equation of a straight line. Now here in England, we use y equals mx plus c. I know some countries you will use b instead of c, but if I give you a breakdown of what each one means, we've got m, that is just your gradient or your slope, and then c, that is your y-intercept, which is just where the line will cross the y-axis. So we are going to rearrange this so it's in exactly that form. We want y before the equal sign, positive, not negative. Then we want x here with its coefficient in front and its value, so positive or negative, and then we will have c here. That could be positive or negative, so we'll have a number here. And if we take a look at this, well, y is positive, so that's perfect. All we're going to do is move the x. We subtract x from both sides, and we end up with y equals, now because it needs to be in this form, we need x first. When we're going to actually write y equals negative x plus 66. So that is our first line. That's our first linear equation. Now the second one here, we have x minus y equals 30. And y is, and looking again at the general form of the equation of a straight line, y here is negative. So we want to move this y over there. We're going to add y to both sides. So we have x equals 30 plus y. I want y on its own. So I'm going to move the 30 over here by subtracting it. And that gives me x minus 30 equals y, and I'll write it around the other way just so it's in this order. Y equals x minus 30. And there we have our two lines. And like I said, we're not going to actually plot them here. I'm going to open up Desmos, the graphing calculator. Ideally, you should be able to look at a linear equation and roughly see what the graphs are going to look like. And from here, we would have with our x and our y-axis. The first equation, this one here, we have a negative x. So as m is the gradient, we have a gradient of 1 here, negative 1. So that means we're going to have a downhill slope, a downhill gradient, and it's going to cross the y-axis, that's your y-intercept, at positive 66, and it's going to cross quite high up. And then I'm going to roughly just sketch something. We won't take it seriously because we haven't actually drawn the values in. And then the next equation, well, we have a positive gradient. There's a plus 1 there. So a positive gradient 1. A gradient of 1 is a 45-degree angle. We won't go into that in too much detail here. And it's going to cross at negative 30. So our second line would look something like that. And then the solution will be here. And those two values, as we know, if I remember, x was 48 and y was 18. So let's go ahead and pop that into Desmos. And here we are. If you haven't used Desmos before, it's a free online graphical calculator. Saves you having to plot yourself, and you can really get to see what the shape of a graph will look like, particularly more complex ones like quadratic and cubic graphs. Now let's put the first equation in. We had y equals negative x plus 66. So you see in the top left corner there's a cursor flashing just there. So if we pull in y equals negative x plus 66, and there's our first line. Where's it gone? We know it crosses the y-axis at 66, so there it is, it's up the top there. And move it over a bit, we might get a bit of a better view. And then our second equation, so you just hit the return key, that is y equals x minus 30. And there we can see it. So we can see where the two lines cross, that is the solution to our simultaneous equation. And if I zoom in for you, hopefully we might get the numbers actually appearing on the axis. No, not quite, but actually if we move it over that way we might actually get them. Ooh, yeah, I think we do. There they are. Let's take a screenshot for you, then I can annotate it. And here it is. And then we have here, you can see y is 18. And then go down, and x is 48. And so back to our working. Don't forget to ensure you get the credit, that final mark. Make sure you say x equals 48 and y equals 18. And that should be about everything. I hope that helped. If it did, go ahead, hit the subscribe and the notification bell to be informed of any future videos. And I'll see you in the next one. Many thanks. Take care. Bye-bye.